Welcome to the GOTO podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Hi there. Welcome to GOTO Unscripted. I'm Fong-Jones, and I'm the field CTO at Honeycomb, and I'm joined by Marit, and we're both here at GOTO Copenhagen 2023. Marit, would you like to introduce yourself?
Yeah, I'm Marit van Dijk. I'm from the Netherlands. I'm currently working as a developer advocate at JetBrains, and before that I was a backend developer using Java and Kotlin mostly.
JetBrains, Java, Kotlin. Yep, that sounds like a very compatible combination of things.
Yes.
Awesome. Well, today we wanted to maybe spend some time talking about developer experience and making for happy developers. So what's to you kind of the most important thing for a developer to kind of feel happy?
Working for a tool company, I want to say tools can help. Tools that, don't get in your way, tools that let you do your job, offer helpful suggestions. I know that you mentioned in your talk earlier today a bunch of tips on, how to get better as a team in developing software. So maybe you want to share or reiterate some of those tips?
Yeah, absolutely. I think there's no shame in saying you work for a developer tooling company. Certainly one of the reasons that I come to work is I feel like our industry deserves so much better, that so many people wind up wasting a lot of their time on doing break-fix work or having their state of flow interrupted. And, there's the opportunity to empower a lot more people to get a lot more done.
Mm-hmm.
Yeah, so kind of in that vein, when I was talking earlier today, I spoke about platform engineering and kind of the important role that developers can play in not just figuring out best practices for their own teams, but also how we think about ensuring that those practices make it out to other teams and that we're not reinventing the wheel a whole bunch of times.
Yeah. Sharing the knowledge that you have or what worked for you and might work for other teams.
Yeah, exactly. The knowledge and also the kind of know-how, the practical kind of implications for what's our process, what's our tooling, as we were just discussing.
Mm-hmm. So one of the things that you mentioned in your talk was you build it, you run it, which I found very interesting. The company I worked at before I joined JetBrains, our slogan was, you build it, you run it, you love it. So, in the DevOps way, you build the code, you deploy it to production, but you also own it in production. So, if you deploy it and something goes wrong, then it's the team's responsibility primarily to fix that, which is very different from what was happening maybe 10 years ago or more, where there was a project organization that would build features and then throw it over the wall to ops, who would basically be like, we don't want to deploy anything. It's sort of running right now. So do you have any thoughts on that? Is that progress in the industry? How does that help developers if they're also responsible in production?
I love the addition of you love it to the end of it, because I think, for too many software developers, they've kind of been forced into on-call just as part of this, you must own your code. And I think one of the things that I said was, it doesn't make sense to make people do something and to give them the wrong tools and to poorly equip them and have them continue to be afraid of production and afraid of what happens if they break things. I think it's much better to empower people, and then over time, they will feel a sense of ownership for it, and they will really develop operational excellence. But as one of the people who came from the ops side, definitely I don't want to go back to the old days of having my pager be on fire and to not have the kind of control to do anything about it, aside from saying, no, you can't roll out new features. No one likes saying no. That's the end. That's really what it boils down to. no one likes blocking or gatekeeping things from going out to production.
Okay, but most people also don't like, having their pager wake them up in the middle of the night.
The solution is to have your pager go off less often, right?
Exactly.
And in order to do that, you kind of have to embrace, making sure that your software is well tested, is making progress towards reliability, is controllable, is predictable. And, yes, insert obligatory plug here, right? Like, you have to have adequate observability. If you can't actually figure out what's going wrong, then it's going to take you a lot longer to figure it out, and it's going to be at 3 a.m. as opposed to kind of more seamlessly looking after your software, being able to debug it if it breaks. But yeah, one of the interesting things though is my boss has caught a lot of flack over the years for saying, the rule of no Friday deploys is bullshit. So people have been like, but my organization, doesn't deploy on Fridays because we respect our developers' weekends or whatever, right? Like, and the point that Charity is making, and that I agree with, is that it doesn't actually matter what day of the week it is. You don't push code at times unless you're able to follow it all the way to production, right? That regardless of what day of the week it is, I do not push code at 5 p.m. and then walk away and leave the pager on fire for my colleagues.
Exactly. So we also had discussions at my previous job. We had discussions on whether we should or shouldn't deploy on production, and Charity was quoted on that. So the way I interpret it is you have to make sure that you are confident enough in that we can deploy this to production. And if you are confident enough that you can deploy this to production and that you know none of the known things will go wrong, and that you're able to deal with what you said, the unknown unknowns, because you have observability in production and you'll know if something went wrong and you have a way of dealing with that, ultimately maybe a revert if you have to. So it means making sure that you know what you're deploying to production and that you feel in control of that and you feel like you've adequately identified and mitigated risks to be able to confidently deploy any day of the week. Of course, we've had issues where we did a post-mortem and one of the questions was, why did you deploy this on a Friday? So this is still a mindset that is in progress, I think.
Yeah, definitely. I think one other piece to this is about keeping context, right? That it's not just about can any one developer, understand what another developer wrote, but is there a kind of this continuity of when it rolls out that the person who wrote it has the state on what's going on, so that they are the first one who's going to look after things if the change did not have the intended effect.
Yeah, and I've been on teams where the code ownership was very much shared. And even though we didn't do a lot of pair programming or ensemble programming, we did do a lot of collaboration on code, or sometimes, every person on the team brought their own, I don't know, maybe niche interest or knowledge or background. And we would have conversations like, oh, hey, can you help me with this topic that you're really good at? Or, they would come to me with, hey, do you want to spar with me on how we're going to test this thing and make sure that it's okay? So very much the whole is better than the sum of the parts, a kind of situation where we would do code reviews and make sure that everybody at least understood in general lines the code that's going to production, so that we are also able to support it if it breaks in the future. Of course, unfortunately, sometimes bugs occur when the person who wrote it is on holiday. So we were very mindful of making sure that everybody had sufficient knowledge of the code that we were deploying and was able to support that code, building, running, and loving it. Or at some times when we weren't really feeling the love, taking a step back and needing to show some love to this code base so that we could confidently run it again.
I love that. That metaphor is going to stick with me for a while. I think the other useful thing to consider there is when you're doing those code reviews, right? Like to ask those questions, right? Like, did you add sufficient testing, or did you add sufficient, right? Like, how am I going to observe this? And how is it that someone who has no previous exposure to this could figure it out from first principles by looking at the output of the data?
Yeah, so some code comments that have happened over time is we had a new developer who joined our team who wasn't a big fan of testing. So the first code review, I was like, maybe give your tests names that actually cover what they're supposed to do, just in case they break in the future. You don't want to, on top of, hey, something broke, also have to figure out what it's supposed to be doing. If you can encapsulate that in the name, like, in this case, this should happen. You can use the given, when, then structure, or act, arrange, assert, which is basically the same thing. But describe the intended behavior in the name of a test. That's going to definitely help you down the road if it ever breaks in the future. Things like that. I would often just put code comments like, can you please explain what's going on here so that I know if anything breaks here, what it's even about. And some of that would go, like, I don't know, offline. We would just have a conversation about what's going on rather than go through code comments. That's what happens if you have a good functioning team where you can just talk to each other. So,
yeah. Although I imagine that that's kind of changed for a lot of companies over the past several years, given that you can't necessarily sit over each other's shoulders.
Not anymore. So when the pandemic hit, I was on a team, on this specific team that I'm thinking of now, where we had the relationship where we would just ping someone and be like, hey, do you want to spar with me on this topic? And because we already had that dynamic, we kind of continued in a similar vein. Of course, it wasn't sitting at someone's physical desk anymore. It was just going over Zoom or whatever, Gmeet or whatever tool you had.
But you've had kind of this reservoir of psychological trust and safety built up with each other.
Yeah,
to do that.
We had the whole team feeling and knowing each other well, and kind of making jokes and so when you already have that basis, it becomes much easier to then work remotely. And of course, if you're onboarding to teams that are new with people that you don't know, getting there online is more difficult. But I've also worked on open source projects where that also happened, where I didn't meet the people that I was working with until maybe a year later, when there was an event where we finally met in person, which felt very 90s. Oh, meeting my online friends in real life. But
yeah, we did one of those about 8 or 9 months ago at Honeycomb, and it was really great to meet colleagues that I hadn't gotten to meet in like 2 years of working at the company together. Yeah, I think one of the other terms that I think I picked out from what you said earlier that I'm going to have to adopt is the term ensemble programming rather than mob programming. Mob programming always has struck me as a little bit weird.
Yeah, that it's not my term. I'm not sure who came up with it, but yes, it's because the mob sort of triggers the idea of people with pitchforks and an angry mob, which isn't at all what Woody Zool intended, but someone came up with ensemble, which sounds so much more nice.
Yeah, and collaborative, right?
Yes.
It's, like a chamber music ensemble.
Yes, which I don't make music with anyone, but that is definitely a community effort where everybody has to do their part in order to make it sound good, which I think is a good concept to keep in mind when building software, which, building software is a team sport, I think.
And it has to be. Otherwise, your code winds up being not looked after if you go on vacation.
Or people, save tasks for you when you go on your honeymoon and be like, we saved this job for you, even though we said we would all do it, but,
Yeah, knowledge sharing also seems to be this thing that, different teams have different practices on. Some teams wind up writing kind of exhaustive documents down into a wiki. Other teams, rely on kind of this shared state that exists in people's heads. But I think either way, right, the important bit is the communication of that state.
Yeah, I like to write stuff down because, I'm getting older and remembering things is getting harder. So, for example, if I join a new team, I see if their code bases has readmes that explains, here's how to run this project, here's how to build it, how to run it locally, how to run the tests. And either there will be like a standard way. So for Java projects, if you're using Maven, it'll be Maven clean verify. If that works, great. I don't need to write it down. If there's additional stuff that I need to do, I write it down in the README, because then next time I don't have to go looking for it. I know where to find that information. And we had similar things for, so we had an engineer of the day. So basically one person on the team, which was rotating every day, who was responsible for answering questions from other teams about our applications or answering questions from business people about our applications, but also like doing daily checks of the health of the system. And we also wrote that down on a wiki page or a Confluence page. Just, look here. If this goes wrong, there were standard things like maybe, sometimes it goes wrong. We haven't quite had the time to figure out how to properly fix it. Or, sometimes this just happens. Here's, just press this button, give it a little push, and now it'll work again. Just writing that down helps, because then you don't have to remember in case it, happens again too far in the future where you don't remember the details. I find that very helpful.
I really love that your team did that, because so often I've come on to teams where everything is getting, we call it kind of the spraying the fire hose, right? Like every single developer gets wet, right? Like you wind up with, all these interrupts that come in, which mean that people can't do their, focus on their day job. Whereas if you, have the on-duty engineer, it kind of really streamlines that. And you could, two teams can have the same amount of toil, whether it be break-fix work, whether it be interrupts from other teams, but they can be in vastly different states of productivity depending upon how that incoming workload is allocated.
Yeah, so instead of every question interrupting all of the developers, it's one person's responsibility to monitor the channel for incoming questions. Of course, if that person happens to be in a meeting and something urgent comes in, like production is literally on fire, someone else can jump on it, but we have one person whose primary responsibility for the day or week, other teams would do it by week, it is to monitor that channel and limiting interruptions, which is, also gets in the way of developer flow, like you mentioned earlier.
Yeah, so I'm really excited for your talk on managing software dependencies. This is definitely something that, at least in my book, it is a category of toil, right? Like it's a category of a thing that doesn't actually advance the system.
Yeah, but it's definitely necessary in order to not degrade the system as well. So it's one of those things where we know we have to do it. We know we'd rather be doing something else. So if we can automate the pain away, it makes our lives easier. So yeah, I'll be talking about different things that you can do to make that easier for developers and different tools that you can use. It'll be geared more towards the Java ecosystem because that's where I live. But some of the categories of tools are also available for other languages and ecosystems. So hopefully, even if you're not a Java or Kotlin developer, you'll get something out of it.
Yeah, there's this kind of interesting paradox of automation situation going on, I think, what's in that topic, in that, you see these like scary warnings being like, hey, like if you automatically apply these updates, you might pull in malware. Oh my goodness.
Oh, well, so that's the other side. So do I always update to like the latest version of everything? No, because then you run the risk of, automatically pulling in malicious software. But also you shouldn't be on like the oldest version, and you should at least update if there is a known vulnerability in your particular version of a dependency that you have, and there is a new version available where they fix that security vulnerability, then absolutely upgrade. Because, if once they are known, then they become known at tech factors. And if you work in any company that's even a remotely interesting target, so I was working in an online retail platform in the Netherlands, which makes you like a well-known, in the Netherlands, a well-known platform outside the
Yes, exactly. No one wants to get ransomed and have their website held hostage.
Exactly. Yeah. So definitely not how you want to end up in the news, which is, which is a question I learned from a tester friend. Like, if you're thinking about what could possibly go wrong when building a new feature, one of the questions to ask yourself is like, what is the worst possible headline that could happen if we build this feature or don't build this feature? And I think that's something good to consider.
Yeah, in the SRE space, we call that a pre-mortem, where you're kind of enumerating your known and knowns, right? Like you're enumerating, here are the risks that I think could possibly go wrong. How am I going to design and defend against that?
I haven't heard that term before, so I'm going to take that.
Listen, this is part of the fun of exchanging these ideas from radically different spheres.
Yep.
So going back to the software update discussion, I think one of the things that I was realizing as I was, digesting this question of, how much time and energy do I spend on manually validating updates versus automatically applying them? What are the acceptable risks? And then I realized, like, if I'm manually clicking through and approving these things, am I actually doing any meaningful oversight, or am I just saying yes, right? Like,
yeah. Do you know what this particular update entails in order to properly evaluate it? But the same can go for code reviews as well. If you're not the one actively developing this feature and thinking about like the best way to implement it, and should I use this pattern or that pattern, or this implementation or that implementation, how much of that are you really going to get from reading the code during a code review? And I guess the same for doing the updates. Like if you don't know what the updates entails, how are you going to properly evaluate whether we can merge this code or perform this update? So then again, maybe pairing and ensembling can be a way to both share the knowledge of how we're implementing this feature, but also asking those questions up front rather than, hey, I've written this code, I've done my very best, because like you said in your talk as well, nobody wakes up and thinks, okay, what crappy code can I write today? Honestly, ever. So, if you do that up front, or even just think about like, how are we going to implement this and get all of the stupid questions out of the way, then the solution they end up with is going to be better as well.
Yeah, I think there's also kind of this element of if two people have worked together very closely for a while, right, like they might wind up rubber stamping each other's changes because they both kind of have this shared model. But you can use that sometimes as an opportunity to bring in someone who's newer and have them do a code review of something that, the person who wrote the code knows what they're doing, right? This is fairly routine, but it's an opportunity to bring someone new up to speed as to like, how does this actually work? What is this doing? Even if it's, the example that I like to use here is infrastructure as code changes, right? Like if I'm changing from trying to saturate our CPUs at 80% to 85%, right? Like that doesn't necessarily require a lot of, so someone could easily like look at a graph, agree that the same graph that I'm looking at says that it's safe, but it's an opportunity to bring in someone new and teach them and show them how it works.
Yeah, so the whole infrastructure as code is where I'm maybe also lacking in knowledge. So those would be very hard for me to evaluate, because sometimes, you have this big YAML file, you have all of these properties. I, as a developer, don't necessarily understand the impact of, particular settings or tweaking them or whatnot. And that's where maybe having dedicated teams or dedicated people who have that knowledge, who can help the developers understand that or what works for their particular situation. You mentioned some of that regarding SREs. So do you have some examples of how SRE teams can help development teams?
Yeah, this is a evolving topic because there are many different models for practicing SRE. The Site Reliability Workbook by Google, the kind of second Google SRE book, goes into some detail as to models that people have tried. So the original Google model was a SRE team, essentially is a operations team that uses software and is comprised at least half of software developers, but it still very much is the team that owns production, and there's a minimal degree of kind of shared responsibility with the software development team. So that was kind of how that started. But there are definitely other models like embedded SRE where you basically say, you know what, you have a collection of SREs, you just spread the SREs out, you put like one or two on each software development team. And then there's kind of the consultative SRE model where every team is responsible for its own production, but you have SREs who are available to answer questions, and that's kind of the genesis of where platform teams come from, I think. It's kind of what can you learn from consulting to kind of give people better practices so that you have to answer fewer questions about what the right way to do things is. Yeah. But yeah, I think the, SREs running the system, soup to nuts, is not really a sustainable model, and it kind of recreates a lot of those pathologies of knowledge being divorced, of teams not having sufficient kind of visibility into the velocity radius of their changes. And the reason why I don't particularly love embedded SRE is that you can very easily wind up having those one or two people be kind of the focal point for all of the operations focused work of that team. It doesn't percolate as well to the rest of the team. And then
because you have one dedicated person who is actually doing it, so they might as well be doing it somewhere else, maybe, because they're not necessarily sharing their knowledge with the team.
Right, or at least it's spreading out more slowly. So those teams definitely do work in that the SRE is not the only person on call at all times, but they certainly are the person writing most of the automation. But yeah, I think it tends to work a little bit better when it's just better spread out. The other thing about that also is the career development. So this is kind of the thing where Facebook was the company to kind of practice embedded SRE first, and they call it production engineering for various historical reasons. But one of the challenges they had was that they wanted to have the production engineers all report to one set of managers. So you would be working for one functional lead, but you would be reporting to someone in the reliability engineer organization, right? So that kind of creates all of these misaligned and weird incentives where your manager is not the person that you're directly working with every day.
Yep. I've been in those situations and it is no fun. So, so we had several different types of platform teams where we had one team that was responsible for kind of our internal framework, which was basically Spring or Spring Boot wrapped with other dependencies that you'd need to build applications in our landscape, who were, they spent their time doing that. They wrote great documentation also on how to migrate to newer versions and what to look for and what the impact was. And they were very available for questions. And then we had maybe platform teams that help with moving to the cloud and running applications on the cloud. And we had a custom in-between kind of system. You asked about who's using the console to configure their cloud stuff or who's keeping it in their code base. So we had it in our code base, but there was a way to also run the configuration elsewhere. And that was the part where I was always confused. I'm not too sure about the changes that I'm making and what their impact is. And then if the people who do know have limited availability and don't have the time to help all of the developers to properly understand that, that's where you get a bit of friction. Do you have tips maybe for how to deal with that from a developer side?
Yeah, I think that it's really important for people to have kind of those common paths, right? To make sure that there is a sensible default way of doing things. And one of the interesting points of feedback then that comes back is when those defaults don't work for people, right? Then you find people who want to, break the glass and press the button. And that's really an opportunity to say, either we need to change the tooling to accommodate this use case, or, this is sufficiently off the beaten path that, that team should go off and do things their own way. So yeah, I think it's when you have that situation that you're describing of you need to go off the beaten path and you're not sure what to do. Right, that's a sign that the platform is probably not providing sufficient guidance, or is not capturing a key use case where people who have an idea of something that they have a good reason to do and don't have kind of a proposal trial they want to do it. I think that's a sign of, okay, we need to design for that use case. Assuming it comes up a couple of times, if it's just a one-off, then that's just a one-off. But more of the time, I tend to see. Here's an example for you. We have we migrated most of our applications to run on top of Kubernetes. We actually just finished that migration a couple of months ago. But one of our applications we knew could not run in the traditional Kubernetes deployment model because it was stateful. It had pairs of workers, one of which had to be up at any time. That was a situation of, okay, the standard patterns of, just create a Helm chart, just use a deployment. That was just not going to work. So that team knew that they had to build out their own custom operator. That was what was going to be needed to manage the individual pods.
I'm sitting here giggling because you hit the nail on the head. I think I ended up in several situations where the standard way of doing things that worked for 80-90% of the cases and 80-90% of the teams and code bases, which is definitely what they were aiming for, automate the basic standard use cases. And then I ended up in teams where we had a slightly different use case that wasn't part of that 80-90%. And then you end up having to figure out how to deal with that, and with, the options provided by the cloud platform that we were using, and also the ones that were allowed by the IT department or architects or whatnot. But then definitely you need more help from the SRE teams or platform teams on how to cover that particular use case. And it could be like, we're not going to include it in our basic or our standard configuration, and we need to go look for something else. So
yeah, right. Like that is, from the perspective of the platform or SRE owner, right? Like that is a useful signal as to which teams I should spend the most time with, right? Like it's those that are kind of pushing the limits of what's possible on the platform.
Yep. But also I understand why, okay, so we have maybe 100 teams. This solution works for 90% of them. And then we have like these 3 teams and they need something else. Do you incorporate that into your platform and make it X amount of times so more complex? Or do you figure out something for those teams who have a different use case?
This is such a wonderful question to ask. And it's one that I wish I had gotten to in my talk, because like it turns out running a platform and writing the software for a platform, congratulations, you're creating a product for your internal developers. You need product managers, developer advocates, right? Like it turns out you cannot just set loose a bunch of backend engineers and tell them, you're building a platform, have fun, and then they'll build something that's completely not end usable. No one's going to use it, right? Like you have to do those. You have to have user research to kind of understand what are the trade-offs, what are we building, who are we building it for, what's going to make sense. Because if you don't have a coherent product management strategy and kind of the input gathering and the evangelism, like you're not. Your only lever there then is kind of fear of, you're going up against the architects rather than building the best thing for your developers.
Yeah, in order to do that, you have to understand their needs and what their use cases are, etc. And it means, again, talking to people, because software development is a team sport. So, yeah.
It's really interesting how software developers have this reputation as, stereotypically as people who don't like to talk to other people and want to sit in their cubicle and write code all day. And like, I think that is the antithesis of like what makes for someone who is a great software developer. A great software developer is someone who communicates well about what they're doing.
Yes. But it's almost as if, we cultivated this stereotype and then that's what we ended up with. So maybe we need to cultivate a new stereotype of developers who like talking to other developers and occasionally business people and other people, and are able to explain what we're doing.
So. Yeah, kind of less of a arcane priesthood, as it were, of people who understand the code magic and those who don't, right? Like, we're here to share it.
Yes. And I would much rather work with people who are also able to communicate about what they're doing than, sometimes you need someone to fix the really hard problems, but most of what we're doing aren't rocket science. We're building, well, in my case, web services. So, it's been done before. It helps if you can explain what you're doing, can talk to the other teams who are using your application, can talk to the business about what they need, and make sure that you're building the right thing. So,
excellent. Do you have any parting thoughts before we wrap up?
It was a great conversation. Thanks so much.
Yeah, thank you for joining us, and please watch the talks from GOTO Copenhagen.
Thanks for listening to this episode of the GOTO podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.